Is there really a face on Mars? Is this the eye of God? Why is there a giant hexagon on Saturn?
When I first saw these pictures, I thought, how the hell do you get that?
What has astronomers blowing things up? And why is one of Saturn's moons a Star Wars look-alike?
It looks just like the Death Star.
Could the strange shapes of the universe now solve mysteries that have haunted mankind since ancient times? Ancient mysteries, shrouded in the shadows of time. Now, can they finally be solved by looking to the heavens? The truth is up there, hidden among the stars, in a place we call the universe. Of all the wonders in the ancient sky, perhaps nothing mystified mankind more than the moon. But what could explain the face that appears on its silvery surface? Was it a magic spirit, or one of many gods ruling the heavens? Some say the face belongs to Cain the Wanderer, son of Adam and Eve, condemned to circle the earth endlessly for killing his brother Abel. Other ancients saw things differently.
The man in the moon is only a man to us. In other cultures, for example, East Asian cultures, many people see other shapes or other faces. In East Asian cultures, it is thought that rabbits live on the moon. And so the man on the moon is actually a rabbit.
Why does this mysterious anomaly look as it does? Is there an answer in science?
The dark areas are ancient lava flows that are reasonably flat. And the bright areas are more mountainous regions where there are lots of craters, and they reflect the sunlight more.
But what did the ancients make of the other imperfections in the celestial sphere? A star that suddenly brightened. A comet appearing to streak through space. The invention of telescopes 400 years ago only deepened the mysteries, revealing strange shapes everywhere.
When we look out into the universe and we see shapes in the distant stars or in other astronomical objects, what we're really looking at is physics as the sculptor, because the more detail that we get, the better we can learn about the shape of that object, and the more detailed we can make our model of how it formed.
For each of the odd forms we see, its shape is the latest chapter in the sometimes violent and often dramatic events that seem to speak to us with a story. Could this be the eye of God? 700 light years away, the haunting image appears in striking variations as modern telescopes photograph its details in different wavelengths of light.
It really just looks like an eye staring down at you from space. And if the celestial sphere is the home of various gods, or the single god, well, gee, maybe this is the eye of God.
To our ancestors, the stars were great mysteries. What were they made of? What was their purpose?
In those earlier times, the view of the night sky is that you had all these bright objects, the stars, the planets, as immutable, everlasting objects.
The strange shape we perceive as an eye proves that stars are not unchanging and everlasting. Like humans, they have limited lifespans.
This is an ordinary star in its death throes, emitting gently its atmosphere out into space. The remainder of the star, its core, is so highly energetic that it's emitting enough radiation to light up this gas in space, almost like a fluorescent tube.
When discovered by telescope in 1820, the Eye of God appeared only as a fuzzy round shape, similar to what planets looked like. Astronomers called it, and others like it, planetary nebulas. Today's astrophysicists call this the Helix Nebula.
Astronomers used to think that the Helix Nebula is a coil in space. And we see it end on, so it looks like this.
More recent study, though, has revealed a different shape hidden in the dramatic object.
It turns out that modern observations have shown us that the Helix Nebula actually has two intersecting rings.
If we could fly around it, the Eye of God is suddenly transformed into something dramatically different. About 3,000 planetary nebulas, like the Eye of God, are known in our galaxy. They come in a kaleidoscopic mix of strange shapes, each a different way a dying star takes its final gasp.
There's the Cat's Eye Nebula. There's the Lemon Slice Nebula. There's the Owl Nebula. One of my favorites is the Eskimo Nebula, because it really does look like there's a face there surrounded by a hood to keep it warm.
Strange shapes also signal the deaths of stars that end their lives, not so gently, but in violent explosions. About 7,000 light years away, odd-looking evidence of such a blast remains.
It was observed in X-rays, and when we look at the structure of it, it appears to have these sort of spooky dark eyes and then a grinning face, almost like a ghoulish pumpkin.
Consider this a literal blast from the past, marking a mystery more than 1,000 years old.
In the year 1006, a bright star was suddenly seen in the sky, and it lasted for many months. It was brighter than Venus. It could be seen during the day. What could this possibly be? We now know that this object is the remnant, the expanding gases of an exploding star, a supernova.
The most famous of the supernova remnants is the Crab Nebula, its shape reminiscent of a crab's shell. Another is nicknamed the Hand of God, for the form its long fingers of glowing gas appear to take. About 300 supernova remnants are visible in some detail through Earth telescopes, each one with a different shape.
In supernova remnants, we see a variety of different shapes. Some look like the @ sign, some look like Q, the letter Q, some look spherical. There's even one that looks like a manatee. I don't know how you get the manatee, that's just crazy.
How can the simple spherical shape of a star explode to create such bizarre remnants? To investigate, astronomer Andy Howell enlisted the help of pyrotechnicians.
Well, a supernova, starts with a star that's spherical, and then sometimes the explosions are spherical, sometimes not. So it'll be interesting to see what we get here.
Okay, let's go over to the firing box and we'll try one out.
Awesome.
Okay.
Expecting to see like a plunger or something here, but
Like the old days.
yes. Are we ready to go? Yeah. All right, 3, 2, 1. Whoa! Whoa, whoa, that looks cool. Let's run that back and see it at the beginning. It's exploding in some not completely spherical way, and we see that in stars sometimes when you light the star off center, you can get an aspherical explosion. And wow, here we really see this plume of material coming out, messing up the spherical symmetry. And sometimes we see that in supernova remnants. You'll see some little jet that sort of shot out of the supernova. So it's not exactly a supernova, but it's pretty analogous.
Some other stellar explosions, as well as the planetary nebulas, are often split personalities. How can a star possibly start out as a sphere and then shoot out in two clear directions?
We're trying to demonstrate how some shapes we see in remnants are bipolar. Explosions happen not spherically, but they come out to the side.
A belt of dense debris may surround an exploding star in space. On Earth, a metal barrier between explosive charges does the same job.
Anytime there's an obstruction, of course, the energy is going to go where it has least resistance. It's going to shoot out.
Okay, so let's fire it, see what we get.
All right, ready to go?
There you go.
All right, 3, 2, 1. Whoa! When we made an explosion with a barrier in the middle, we get these beautiful lobes go out on either side. We see that in a lot of astrophysical contexts where you have a ring or a disk of material and it obstructs the explosion or the mass loss from the star, and you see stuff flying out in these lobes.
Of all the bipolar shapes in the cosmos, there's one that's attracting special attention. The double cloud of glowing gas hides a giant star, now thought to be an ultra-powerful supernova in the making. What makes it so different? And why do some think it could wipe out millions of species on Earth? In searching space for its strangest shapes, a certain spot near the Southern Cross constellation stands out. There, our ancestors were once perplexed by a sudden mystery from an ancient star named Eta Carinae.
Eta Carinae is a star that was relatively obscure for a long time, but in the early 1840s, it brightened to become the second brightest star in the sky.
A century later, another layer of mystery enveloped the strange star.
In the 1940s, telescopic observations of Eta Carinae showed that it wasn't just a point-like star, but rather it had a nebula, a cloud of gas around it. And in fact, the shape reminded people of a little man with stubby arms and feet and kind of a pointy head.
The nebula was nicknamed the homunculus, for the human-like creature alchemists were once said to have created in their laboratory flasks. Today's telescopes give us a very clear view of the gas cloud. What forces were at work to carve out this strange shape? To explore the answer, astronomer Laura Danley wants to bring the nebula down to Earth. Cutting-edge 3D printing will allow her to hold the homunculus in the palm of her hand.
It actually breaks it up layer by layer into essentially the path that's going to get traced out by the 3D printer.
Wow, that's not too different from what the scientists did when they observed it.
In 2014, astronomers took about 100 telescope slices of the homunculus, essentially scanning it in 3D. Now, the printer uses the data to deposit plastic filament onto a platform, where over the span of 8 hours, the telescope slices take solid form.
It's amazing to be able to hold in my hand the homunculus nebula. I observed this myself as a grad student, but to be able to look at it and see things you can't see from Earth is really an amazing thing. For a long time, we thought that Eta Carinae was just a single star. So we now know that there is a binary pair. What we didn't know is, did the binary pair have any influence on the shape of this homunculus nebula? Now with this 3D model, we know that it did.
Dimples and ridges on each end of the nebula, plus 2 distinctive protrusions are the key clues. Inside the nebula, the binary stars circle each other, one 30 times the mass of the Sun, the other 90. Each one emits intense outflows of particles called stellar winds. The smaller star whips around the larger one, carving a tunnel through its stellar winds, leaving physical imprints on the nebula's cloud. The story of Eta Carinae, however, is far from over.
In the future, we know that Eta Carinae will actually undergo a final explosive death. And at that point, when it does explode, it'll crash into these gases that it had previously ejected, and this will cause it to become enormously more powerful than just a typical run-of-the-mill supernova.
Some believe it may produce a gamma-ray burst, a deadly beam of radiation that could cause a mass extinction here on Earth. Most astronomers, however, say it's too far away, and the beam wouldn't be a direct hit. So we're safe for now. Human-like shapes, such as the odd homunculus, are actually everywhere in the cosmos. Could the universe be trying to get our attention?
When we look around us and see these incredible shapes in nature, we map them into things we're familiar with on Earth, like a butterfly or a face or an eye. And that's this phenomenon called pareidolia. It just means our monkey brains evolved to recognize things that would be of interest to us as people.
Faces in particular jump out at us everywhere. Like the ancients, we still see the man in the moon. The sun recently had surface activity looking like a face, and if you look carefully on Saturn's moon, Dione, you'll see a face there too. But Saturn itself is the epitome of strange shapes.
It's said that beauty is in the eye of the beholder, but I know few people who don't think that Saturn is beautiful.
The ancients assumed the planet was a simple sphere. But when Galileo first saw it through his telescope in 1610, the fuzzy image opened up a new celestial mystery.
When Galileo originally observed Saturn, he had really a rudimentary telescope and not great eyesight. So what he saw was a planetary body, or something that appeared to be a planetary body, with lobes off of the side of it. And so he drew in his notebook a planet that had these lobes and arcs off of the side of the planet.
As Saturn and the Earth each revolve around the Sun, Saturn's angle, as we look at it, is always changing. For early telescopes, it was a challenge.
One of the additional difficulties would be the fact that that fuzzy shape with the two ends would actually be changing. And that's because, of course, the rings are changing their tilt one way or the other as we look at them. When they're edge on, they would actually almost disappear. So it would have been very confusing as to what could make that shape change.
When astronomers concluded Saturn had rings, the problem was solved. But it took some 17th century out-of-the-box thinking.
It was really an amazing insight. No one had ever seen or even thought about something like it. They had seen planets through telescopes and they were all round, but to imagine a planet with rings around it was really a leap of imagination.
But the rings aren't the only strange shape circling Saturn. The planet is surrounded by a mysterious array of weird objects. Among them, 62 known moons.
My favorite Saturn moon is Mimas, because it looks like the Death Star. It looks just like the Death Star. In fact, in Star Wars, they say, that's no moon, that's a space station, and that's what it looks like. But we know that the laser death ray on Mimas is actually just a crater. There was some giant impact in its past.
But the most mysterious shape in the Saturn system is on the ringed planet itself. Centered on its pole is a bizarre shape that seems impossible in nature. Could it be a sign of intelligent life? Strange shapes and patterns in the heavens have mystified mankind for thousands of years. While modern science can explain many of the phenomena that baffled the ancients, it has also uncovered new mysteries that we're only beginning to understand. The rings of Saturn once puzzled our ancestors. But recent close-ups reveal a shape that seems to defy explanation. A hexagon at Saturn's North Pole.
When I first saw these pictures of Saturn, at one of the poles, there's this hexagon shape. I thought, how the hell do you get that?
The clouds making up the hexagon form 6 straight sides, each 8,600 miles long. 4 planet Earths would fit inside of it. How can nature create this seemingly impossible shape?
It's thought that the hexagon is formed when winds of differing speeds next to each other are actually creating vortices or rotations in the atmosphere.
But rotations in an atmosphere speed up to become storms. It happens that way on Earth, where swirling storms produce hurricanes or tornadoes, all more or less circular in shape. The same is true for the other gas giants in the solar system. How can something round end up creating something with 6 straight sides? This laboratory simulation in a tank of rotating fluids may reveal the secret. 6 swirling vortexes around the edge work together to create the familiar shape. The vortexes on the ringed planet are thought to be atmospheric cyclones, large storms the size of Earth that are not visible from space. Most of the action is apparently below the surface.
The very sharp corners of the hexagon are the places where there are pinch points between 2 cyclones. So it looks like it's kind of an unnatural shape in nature, but in fact, it's very naturally shaped by those storms.
The extreme winds and chemical clouds of the gas giants create strange shapes in a realm of wild fluid motions. But on the rocky planets of the inner solar system, other forces are at work. The planet Mars is especially rich in weirdly shaped rocks and landscapes.
We see a lot of strange shapes on Mars because now we have so many satellites and robots on Mars that we're seeing so much of the planet, there's just a lot more chance to see cool stuff. In fact, Mars is the only planet we know about that's entirely populated by robots. Of course, it's robots that we sent there.
The mysteries of Mars began in ancient times. Its red color led the Chinese to call it the Fire Star, and the Romans to name it for their god of war. 19th century astronomers thought they saw canals built by aliens on a Mars rich with vegetation. The notion of a powerful Martian civilization lasted well into modern times, when space probes revealed the truth.
From our spacecraft that we have observing Mars today, we know that Mars is not a rich, lush environment that has life and plants on it. From the photos from Mars, there are just a host of strange shapes that we can see, either from orbit or from the surface. Things like smiley faces in craters, man on Mars, footprint-shaped craters, heart-shaped craters, and on the surface we see rocks that look like rodents, frogs, blueberries, bones, traffic lights, just a whole host of different things that we can see.
Photos from Mars are posted online every day, and amateur observers have an internet obsession combing through them to pick out weird objects. Could these be evidence of intelligence, as some of these amateurs believe? Or is nature just teasing us?
Well, there's millions of rocks on the surface of Mars in various configurations. In a chaotic system with so many different variations, nearly any conceivable shape will be visible somewhere at some point in time.
And those shapes can change. In 1976, a Mars orbiter saw the infamous face on Mars. But in 2001, a more advanced orbiter saw the same feature. With different lighting and higher resolution, the face virtually disappears. Nevertheless, we have an innate human tendency to see familiar forms in all kinds of objects, even here on Earth.
At the top of this crest right here, I see what looks like a toad or a frog. And if we turn behind us and tilt our head slightly, we can see the facial features of something that looks almost like a troll or a goblin. So it really demonstrates how you can take a very unfamiliar looking terrain and find features in it that look very familiar to us.
The shapes on Mars teach us about the environment that formed them.
Today, Mars is a very dry, windy place. And so the only forces that are really acting upon rocks today on Mars are the wind and impacts. Earlier in Mars history, if Mars was a much wetter place than it is today, water would have also contributed to the shape and appearance of the rocks on the surface.
Wind and weather may explain how the rocks on Mars take on so many different shapes. But what explains the even more bizarre shapes hurtling towards us through the far reaches of space? Among the glistening stars fixed permanently in ancient skies, an occasional misbehaving intruder would strike fear into the hearts of the earliest astronomers. Today we call them comets, from the Greek word for long hair, an allusion to their glowing tails. To our ancestors, they were invariably bad news.
Comets were terrifying to our ancestors. They didn't know what they were, they didn't know where they came from, they just appeared, and they were unlike anything they had ever seen before.
Records of comet sightings go back at least as far as 1600 BC in China, where they were known as vile stars. Other cultures blamed them for various calamities. The murder of Julius Caesar in Rome, the Black Death in England, the arrival of the conquistadors in South America. Modern science tells us comets are dirty snowballs, collections of ice and dust left over from the solar system's formation. The sun heats them up, and jets of matter stream out to form their spectacular tails. But the closer you look, the stranger comets become.
Even through a telescope, we didn't really know what the true shape of a comet was until we were able to send spacecraft out to visit them and look up close.
The spacecraft Giotto made the first flyby in 1985, revealing a close-up of Halley's Comet. It proved that comets are lumpy objects in the strangest of shapes.
And now that we've gotten up-close views, we see that they don't look anything like we thought. There are a handful of them that are sort of roundish, but the majority of those we've seen have a double-lobed shape.
In 2004, the Rosetta mission was launched on a 10-year journey to orbit and place a lander on a comet more than 300 million miles from Earth. Prior to the launch, the Hubble Space Telescope snapped 61 grainy photos of the comet. By analyzing tiny fluctuations in its brightness, astronomers calculated its approximate form, an irregular lump tumbling through space at 2 revolutions per day. But in late 2014, the probe finally approached the comet, and scientists were shocked at the bizarre shape they saw.
The very recent Rosetta mission took exquisite photographs of Comet 67P, showing that it actually resembles a rubber ducky.
It would have been awesome if it was a real rubber ducky, but it's just a bunch of rocks that look like a rubber ducky.
The thing is, we don't really know how you make a comet that is this shape. it's extremely complicated, and we didn't really expect to see something that was that shape to begin with.
There are a couple different ways in which comets could get that double-lobed shape. One is, indeed, two objects that sort of stick together, that when they don't collide with enough force to bounce off each other or shatter each other, but just to sort of stick to one another.
But could Comet 67P have formed as a single object, getting its curious shape later on?
Now, you could also imagine that some of the cometary physics is at work in sculpting this particular odd shape. As the comet comes into our inner solar system, gases start to stream off from it as it gets heated up by the light from our sun. You can think of these a little bit as though they were like geysers on our planet. Geologic activity where warmer material starts to stream out of the comet, possibly causing cracking and reshaping of the surface.
Could Rosetta's up-close view tell us which of the scenarios is the right one?
Recent observations show that the composition of the two lobes of 67P are very similar, that suggests they came from the same body. We also see that most of the outgassing comes right at the neck of the rubber ducky, right at the thinnest part. So it wears it away and leaves two big lobes on either end.
Comets are the lightweights in nearby space. The asteroids and dwarf planets are their big cousins. Heavier, denser, and in many respects, stranger. What forces mold these planetary mavericks? And why, in their midst, is there a place in space where X marks the spot? Planet Earth has always been a target for impacts from space. A giant impact may have killed off the dinosaurs about 65 million years ago. And ancient mythology is filled with legends of rocks from the sky. The Greek deity Kronos is said to have cast a meteor to Earth, landing at Delphi, where it was worshipped as sacred. This brings the search for strange shapes in the universe to the space between Mars and Jupiter, where the oddly formed asteroids are found.
Most meteorites come from the asteroid belt. They're little chunks of asteroid that, through collisions, got knocked off their orbits and fell to Earth.
Austria, 1492. The 250-pound thunderstone of Ensisheim falls in a fiery streak. A thunderclap is heard for hundreds of miles around.
Like comets, meteorites were bad news. Emperor Maximilian was so worried about the meteorite, he had it chained to the church floor because only by securing it to holy ground could he neutralize the evil influence.
Mysteries among these space rocks persist today. An eerily ominous shape appeared in the asteroid belt in 2010. Why did an X suddenly appear there, with a trail of debris lagging behind it?
Here we have a very unusual asteroid that has a tail. It looks like a comet, but further observation showed that it has no gas in the tail like a comet would. Instead, the tail is made of dust.
Scientists believe the mysterious debris tail resulted from a small asteroid striking a much larger one. But why the cloud of dust in the shape of an X?
One possible explanation for the X shape is that it's caused by a collision. The two asteroids were not symmetrical, and so the crash is not symmetrical. Imagine a pool of water. If you drop a single drop into it, you get perfectly round, smooth ripples. But if you drop something else, like ice cubes with square edges, you'll get a ragged splash, kind of like the ragged X in the asteroid crash.
Collisions help make the asteroid belt an astronomical sideshow, made up of a fantastic variety of misshapen freaks. Asteroid Eros may look like a ballet slipper to some, But other asteroids are grotesque figures that defy description.
The lumpy, irregular shapes of asteroids are basically pretty random. There's no favored shape.
In fact, irregular shapes are found throughout the solar system. But why are some moons or asteroids round, while others are such bizarre lumps?
The largest objects in our solar system, and even some very large asteroids, can have their shape be dominated mostly by gravitational forces, pulling things into a spherical shape.
In the solar system, everything above about 400 miles in diameter is spherical because at that size, gravity is strong enough to crush rock. It presses from all sides toward the center. It's something like someone's hands pressing on a lump of snow to make a spherical snowball. Gravity has done its work on Ceres, the most massive object in the asteroid belt. The Dawn spacecraft began orbiting the asteroid in March 2015, revealing it to be fully spherical in shape. Because its shape is dominated by gravity, it conforms to the definition of a dwarf planet. Pluto and other dwarf planets in the outer solar system follow the same rule and are also spherical in shape.
The one exception to this in our solar system is the dwarf planet Haumea, which has a very elongated shape. Haumea lies out beyond the orbit of Pluto and is actually spinning so rapidly that the centrifugal forces that it experiences are enough to stretch Haumea to a much more elongated shape.
But beyond Haumea, beyond the solar system, beyond the galaxy, the search for strange shapes extends into the depths of space. There, the ancients viewed a fuzzy patch among the stars of the constellation Andromeda. They were perplexed by what it was, scarcely knowing it would one day help solve a fundamental mystery to reveal the ultimate, true size of the universe. More than 1,000 years ago, stargazers identified something strange among the stars of the constellation Andromeda. Neither a star, a planet, nor a comet. It was an indistinct smudge, and a mystery unsolved for centuries.
My favorite strange shape in the sky is the Andromeda Nebula. That's what people used to call it because they just saw this smudge, and they used the word for cloud, nebula.
Stranger still, the first telescopic photo in 1888 showed its oval form with spiral arms. No one realized that the intriguing Andromeda Nebula would upend humanity's view of the universe.
Initially, the entire universe was thought to consist of our galaxy. All the stars in our galaxy, all the stars we see in the sky, everybody thought, well, that's just it.
One of the puzzles about what were called nebulae at the time was exactly what they were and where were they? How far away were they?
Was the Andromeda Nebula relatively near or impossibly far? The key clue came in 1908 from Henrietta Leavitt, one in a team of women paid 25 cents an hour at Harvard Observatory to analyze telescope photographs on glass plates.
Henrietta Leavitt had spent a lot of time studying particular types of variable star, how those stars change their brightness.
These so-called variable stars expand and contract in a regular cycle, almost as if they are breathing, getting brighter and dimmer, brighter and dimmer. Leavitt discovered that you can tell how bright certain types of variable stars are by how fast they're pulsing. The slower the pulse, the greater their overall brightness.
If two variable stars are pulsing with the same cycle, we know that they have the same overall brightness. Now take one of them and move it far away. It looks dimmer to our eye, but by counting the pulses, we know it's as bright as the near star. So we can use that difference in apparent brightness to calculate how far away it is.
legendary astronomer Edwin Hubble then took up the detective work. On October 5th, 1923, he examined the Andromeda Nebula and detected a variable star that has been called the star that changed the universe. Counting the pulses, he figured its distance, which is now known to be 2.5 million light-years away. The distance seemed impossibly large, so large, in fact, that it led to only one conclusion.
It turns out that the Andromeda Nebula is a galaxy full of stars. It's another galaxy that's even bigger than our own galaxy.
In fact, the mysterious little cloud of the ancients was not alone. Telescopes revealed others like it, each of which was also a galaxy. The universe had billions of them.
When we learned that Andromeda was outside our galaxy, it was a revolution in our understanding and our place in the universe. So this strangely shaped nebula that no one knew what it was really held the key to unlocking a universe of galaxies.
Today, astronomers marvel at the number of galaxies observed in the cosmos. Some of their strangest shapes are caused when two galaxies come close together and are twisted or distorted by gravity.
In some cases, they end up looking very peculiar, like there's the tadpole galaxy that has a galaxy with a long tail, looks like a pollywog. There are the mice, two galaxies with two tails sticking out. There's the antenna galaxy, again, two galaxies with two antennae sticking out.
We live in a universe full of strangely shaped galaxies, each populated by strangely shaped asteroids, comets, and nebulas, and full of planets covered with strangely shaped rocks. From our ancient ancestors seeing a face on the moon, to modern scientists spotting a giant hexagon on Jupiter, the heavens have concealed mysteries across time and at every scale.
Maybe the most grand structure in the universe is this filamentary web structure that connects all the galaxies together. It's like this scaffolding of the universe, maybe the skeleton of the universe.
The latest version of the cosmic skeleton is generated by the Illustris project, a massive supercomputer simulation. Like the diagrams and models of the celestial sphere created by our ancestors, it essentially encompasses the entire visible universe. Breathtaking in scope, it displays the structure of the cosmos in minute detail. It is a big picture view of literally everything we can see. And in a universe of strange shapes, it is surely the strangest shape of them all.